So I'm Athan Reines. My background originally is I did a PhD in biophysics and then kind of worked my way through various startups, came over to Silicon Valley, worked for a data center infrastructure startup where I was doing analytics and data science, and then moved my way into like full stack development. And the entire time I was using Node. And so my experiences both in academia, doing research, especially with large-scale images, et cetera, and also in the startup world have kind of informed my my viewpoint on how you do numeric computing in Node.js. And it's not exactly easy, and we're going to go through that journey in terms of like what you need to watch out for, what you need to take into consideration, and then also, if you want to get started in this, like what you need to do. So with that said, I need to do a quick little survey just so I get a pulse of the room. How many people have done what they consider to be numeric computing? That can be machine learning, statistical analysis, data analysis, natural language processing, time series stuff, any kind of buzzword that goes with numbers. Yeah, okay, so a few of you. Okay, and then just in terms of like technologies used, how many people have used R? How about Python? Okay, how about MATLAB? Mathematica? Anyone use Julia? Awesome, we got a lone stalwart here. Excellent. So I need to also ask this question. How many people have used JavaScript before? Awesome. And then how many of you have tried to use JavaScript for numeric computing? Nice. OK, more than I expected, to be quite honest. All right. So the kind of feel for this talk is it's going to be a bit of a roller coaster. And it's going to be an emotional journey as we kind of like weave our way through the world of numeric computing and JavaScript. But don't get discouraged. There is a light at the end of the tunnel. You just need to stick with me in terms of like how we're going to usher in the JavaScript computing revolution. So the first thing I'll talk about is this. I'll try to motivate why you should care about JavaScript for numeric computing. I'll then talk about the state of JavaScript. In particular, I'll talk about the state of math in JavaScript. I'll talk about the state of the ecosystem for doing numeric computing. I'll talk about a project that I'm working on that helps push this conversation forward. And then I'll talk about the future in terms of how you can get involved. And when I use JavaScript, I'm also talking about Node.js, because I'm kind of branching out in terms of, like, if you're doing Node.js, you should also be thinking about how you do these things with JavaScript in general. So with that said, we need to start off with JavaScript, right? And whether you like JavaScript or not, I mean, we're all here, so we probably like JavaScript at least a little bit. It is the language of the web, and that's a capital T-H-E. You can't really get around using JavaScript either on the server now with Node.js or in web browsers for web applications. And whether you like it or not, it has some good parts and maybe some bad parts, depending on your bent, using kind of a controversial example here. But when people think about numeric computing, the traditional languages they think about are R, Python, MATLAB, Mathematica, maybe even Julia now, right? But they're not necessarily thinking about how do I do things in JavaScript and how can I do things in Node.js, right? And we should ask ourselves, like, well, why is that? What are kind of the typical reasons people use for not using Node.js or JavaScript for numeric computing? The first reason is, if they're like old C, C++, Fortran stalwarts, they're like, well, it's dynamically compiled. But we've seen a dramatic shift in how people do numeric computing towards scripting languages like R and Python, which are also dynamically compiled. They also say, well, you don't have 64-bit integers. I care about my dollars and cents, forgetting the fact that you can do financial arithmetic and floating point. But the reality is also in R, you don't have 64-bit integers. They say, well, you don't have native big number support. Well, in R, you need an external package. In MATLAB, you need an external toolbox. So these aren't deal breakers. They say, well, it's single-threaded. Well, so is R. And in fact, JavaScript probably has a little bit of an advantage in the sense that if you're doing I/O, it's event-driven, it's asynchronous, and you can still do concurrent applications. But then they go, it's kind of like the kind of umbrella thing. Well, isn't JavaScript slow? And this may have been true in the past, right? Before you had the browser wars where browser vendors were competing and optimizing code to as much as they could. And now when you do benchmarks, and I can show you these benchmarks, the performance kind of scale goes like C, C++, and then it goes to Julia, and then it goes like JavaScript interfacing with C, and then it goes like math implementations implemented in JavaScript, and then Python, and then at the very end is R. R is really slow. So performance isn't necessarily a deal breaker because people who are doing data science and numeric computing are using slow languages already. JavaScript would probably give them a little bit of a speed bump, in fact. And then they go, well, you don't have C, C++, and Fortran bindings. Because the kind of dirty secret within numeric computing is the fact that like R, Python, Julia, they kind of provide wrappers for low-level C, C++ libraries that have been around for 20 to 30 years. And so if we're talking about like JavaScript in the early 2000s, sure, you're working in a web browser, you can't interface with C. But now that we have Node, and with its rise to prominence and the legitimacy it's given to JavaScript, we can write Node.js native add-ons that can interface with these libraries. So what was true in the past, that people were kind of informing their biases and their stereotypes about JavaScript, is not necessarily true now. So all of this to say is that there's no necessarily technical limitations why we can't use JavaScript for numeric computing and why we can't use Node for numeric computing. But there are two more substantive reasons why it may be a bit more difficult for people to do numeric computing in JavaScript. The first is just community. Now, in terms of just absolute size, the Node.js and JavaScript community is huge, right? But the people doing interesting things in numeric computing with JavaScript is really quite small. So if you're going to do this, it may be a bit of a lonely endeavor, right? And so for some people, that's not optimal for them. And the other reason that also kind of goes hand in hand with this is kind of a lack of comparable libraries. There's no NumPy for JavaScript at the present moment, right? And that's kind of a deal breaker for many people if they need to do applications here or now. But this is not a language or platform or ecosystem. I mean, it may be a bit of an ecosystem, but it's not a runtime issue. JavaScript and Node.js can handle numeric computing just fine. It's just a matter of we need to build these libraries so that people aren't limited in the first place. So that's great. I've told you kind of maybe why JavaScript and Node, like there's no technical limitations for like why you can't do JavaScript, but I haven't told you why you would want to do it in the first place. I haven't given you the positive reasons. And there are several reasons why you might want to do numeric computing in Node and why you might want to do it in JavaScript in general. The first is you want to be able to take advantage of web APIs. So you want to run like isomorphic applications, and you want to be able to take advantage of like hardware that you can get in the browser, like through the webcam or through audio or whatever else. Another reason is you want to take advantage of browser rendering capabilities, Canvas, SVG, WebGL. Next is you want to have a tighter feedback loop between your data visualization, like how you actually analyze your data and the actual computation that drives that. Next, you want to take advantage of just sheer ubiquity, the fact that you can run JavaScript in the web browser. Now, with every single Fortune 500 company running Node in production, you can run on the server, or increasingly in IoT, or if you want to do cross-platform desktop apps, you can do that with Electron, right? So if you want to talk about just sheer ubiquity, JavaScript is your answer, right? It can run pretty much anywhere and everywhere. Next is this distribution. The fact that you can share your machine learning library or your numeric computing application just through giving someone a URL, or in Node.js land, just giving them the name of the package that they can kind of download and use within their own business application. So distribution is key. And next, you want to take advantage of package management. So more or less, if you've experienced package management in other platforms and environments, you've used pip, or you've tried to use packages in R, or you've tried to use Julia packages, you know it can be a bit painful. And one of the things that I think that Node and NPM have kind of gotten right is how you do package management, particularly how you think about semantic versioning of your dependencies, which is important if you want to think about reproducible numeric computing. But there's one more big reason why you want to think about doing numeric compute in Node and in JavaScript, and that's just the type of applications that you can do. First is you want to think about edge computing. So this is the notion that why run numeric compute jobs in your own server infrastructure when client machines can do this just as well and just as easily? Why can't you take better advantage of a person's graphics card or their 4 cores on the machine when you're giving them this application? Like, you can do a lot of machine learning, et cetera, outsourcing that to them. You don't necessarily need to host your server infrastructure to support that kind of computational load. Next is you want to think about cross-platform, which you've already touched on. Maybe you have compute-intensive applications in Node and in JavaScript that you want to be able to take advantage of compute capacity. Another reason is you want to think about interactive data analysis. This could be you're ingesting server data and you want to display a dashboard. Like, how do you think about providing sampling, filtering, feature identification, and extraction within the application itself, rather than having to shell out to R or to Python or some other environment to do this kind of computational load. Next is maybe you want to do some integrated machine learning within your application. Or maybe you want to do applications that are AI powered. Maybe it's like augmented reality, or you want to think about image tracking or object tracking through images. So there are lots of reasons. But there's one other reason you might want to think about, and that's the ability to do mad science. The place to do mad science right now is in the Node ecosystem. This is just a true fact, right? Like right now, you can do like a peer-to-peer serverless grid computing over WebRTC with Node and JavaScript using web technologies, right? You got to think about the web platform is amazing, and Node and JavaScript can tap into that to do applications which are not easily accessible in other languages and platforms, right? This is available in Node. So that's great. You may be thinking, all right, I'm getting kind of excited. Maybe your interest has peaked a little bit, and you're going, all right, how do I get started? Great. Well, at this point, we need to talk about the state of math and JavaScript. And I'll go ahead and tell you it's not good, right? Remember, it's the roller coaster. Yeah, we're going on this emotional journey. So the first thing is, here's your standard library for JavaScript, right? It's 35 functions. If you're familiar with like modern languages like Go or Rust, this standard library for math is really quite small. And if you're familiar with like R and Julia, this standard library is downright tiny, right? You're going, what am I going to do with that, right? So that's an issue. One is just the size of the standard library. Next is there are some specification issues you need to get around. The first is for math and JavaScript, there are no standard algorithms within the specification. The specification for JavaScript does not say, thou shalt only use this algorithm. Vendors are free to choose whichever algorithm they want. Another thing about the standards is there's no minimum precision. There's a recommendation for precision, but browser vendors are free to make precision and speed trade-offs. And in fact, they have, right? For like gaming, you don't necessarily need super accurate implementations. And so you can kind of like sacrifice precision to get a little speed bump. But you can't do that in numeric computing because you need to think about reproducible results. And there's another issue about portability. Because there's no standard algorithm or no standard precision, you go from one engine to the next, that can be V8 to Chakra, and you have no guarantee that they're running the same implementation. So that means if you do your machine learning algorithm here, and then you try it another platform, it may not give you the same results, right? And it's also the case that we live in an evergreen environment. So even in your browser, one browser restart to the next, you have no guarantee that the implementation from one moment to the next will be the same, right? Which is fine for many applications, but not for numeric computing. There's also no common code base, right? Because of how the JavaScript community works, you have a specification, and then you have people implementing it. It's not like Julia, we can just go to a repo and file an issue. You have to go across many different vendors, many different implementations, and try to progress the agenda forward, which is very time-consuming and difficult. Next is this at the specification level, there's a slow pace of innovation, right? So I'll point to int64 support. The reality is that int64 support, proposals have been on the table, off the table, on the table, off the table for over a decade now. Most recently on the table in the form of a big int arbitrary precision integer format, which is like Python 3 in particular. But the fact is, it takes a long time to get cross-browser consensus. So if you really want to be able to drive the conversation forward with numeric computing at the standards level, you better grit your teeth because it's going to take a long time. Another issue is bugs. You would think like 35 functions, they must have nailed this since like the mid-90s, right? Yeah, I like how we can all laugh at this, right? This is quite funny. Because right now in V8, like what I'm running right now, like MathPow, like 10 to the 308 gives a result that's 3 ULP off. That's 3 units in the last place. That isn't necessarily huge. Like it's not huge, but it does have ramifications. And the reason why I first noticed this is because I was trying to do high precision implementations, and I kept on getting unexpected results because these errors propagate, right? And it just so happened that once I dug further, there's lots of errors within these various standard implementations, including the current Node.js LTS version, right? A lot of the implementations there are incorrect. Another example is e to the x, also incorrect. This happens to be in Node version 6. It's off by 26 ULP, which is massive when it comes to high precision. And the reason why this is so important is because, as I said, these errors propagate downstream. And when you're talking about whether someone has cancer or not, these things matter, right? These things are foundational. So if you can't get your standard library right, most likely these things are going to cause your higher level implementations to be wrong. So that's great. You're like, OK, there's lots of problems. And you're going like, what's being done? And the answer is like, not much. Sorry to say, yeah? And there's arguments to say like, why, I mean, it's not even clear whether we want to fix this at the specification level. And the first reason is the fragmentation problem that I kind of alluded to earlier, which is the sense that if you had to have different vendors all implementing this independently, chances are at least one of them will be wrong. And so you'll have like a portability problem. And the portability problem is exacerbated by the versioning problem, which means that in any given runtime, I can't specify what version of a standard math algorithm I have or I can use at a given time, right? Which is an issue, because that means that you're just not portable at all. There's the flexibility problem. Now, the reason that's kind of like coupled with the backward compatibility problem, the reason why the specification is loose, there is a logic to it in the sense that browser vendors wanted the ability to like not shut doors prematurely. They were like, well, if we say we're only going to do this particular implementation, what if a better one comes along? We want to be able to use that. So they kind of like hold out, and by doing that, they kind of avoid this backward compatibility problem. Because if they were to change it later on, they could quote unquote break the web, right? And that's kind of an issue from a standards perspective, right? So it's not clear that we'd want to change the spec to accommodate this for numeric computing in order to address that issue. There's also the globals problem in JavaScript, which is you can't guarantee that some other library hasn't hostilely taken over or hijacked the math implementations. There's also the testing problem in the sense that browser vendors have typically not done rigorous testing of their implementations. And there's also just the trust problem, which kind of underpins everything, right? Right, so we're probably like on the trough, right, heading down. We're on this roller coaster. It's not looking so good. But you're like, wait a minute. We're going to ramp back up. I know what happens. Anytime the spec has failed us, the ecosystem has risen up to the challenge and given us amazing libraries, right? It's JavaScript. You can find implementations for everything, right? Surely the ecosystem has risen up to the challenge. So in that, we turn to the state of the ecosystem. And unfortunately, it's not good. So the first issue is that many implementations of JavaScript and Node.js have false assumptions. The first false assumption that they make is they assume a good standard library. And that ain't true, right? That ain't true at all. So automatically, you're behind the 8 ball if you assume that. The second issue is that many authors try to chase low-hanging fruit, right? There are so many packages out there that do like mean, variance, and standard deviation of an array. That's fine. Like, you have your own style and ways of doing things. Cool, do that. But if you're going to do it right, right? And the issue is that there's lots of poor implementations. People haven't done their homework in terms of how to implement in a rigorous fashion these type of algorithms for like statistical analysis and machine learning. And that's an issue, right? They haven't done their homework. One of the standard litmus tests I always have is I just want to see how they calculate the variance. Because like the standard textbook definition where you have like the sum of squared differences is not numerically stable because you have overflow possibilities or you have catastrophic cancellation. And there are better algorithms for doing this in a numerically stable way. 99% of the libraries out there don't do that, right? They all fail this basic test, and I automatically just discard it because it's not even worth it. Another thing is insufficient scope. So people have done really cool proof of concepts, like people have done deep learning in browsers, like Andrew Karpathy's CovNet.js. They've shown this, awesome. Or there's like WebBlast, which tries to implement BLAST algorithms using WebGL shaders, doing this stuff on the GPU. Awesome. But these are insufficient in scope. You're not going to build a general purpose computing library on top of this, right? They're nice proof of concepts, but you can't scale them. The other issue is this lack of ambition, right? So a few years back, there was a developer, Mikko Lysenko. Some of you might be familiar with him. He developed a package called NDArray that showed that the multidimensional data structures that you have in Julia and R and Python, there's no secret to them. You can implement these things in JavaScript and do efficient multidimensional computation. But the community has not really coalesced and found a robust solution or a robust platform around this kind of like thinking of how you do think about multidimensional data structures and creating efficient algorithms. Instead, people are doing like this nested arrays of arrays of arrays of arrays, which is really computationally inefficient. Not looking good, right? So there's a lot of noise, right? And there's a lot of noise coming from people that do not have the authority or expertise to be making noise in the first place, right? There's a lot of fake news out there. And it's very much true within JavaScript and the Node community, right? So it ain't looking good. It ain't looking good so far. But people have recognized this problem. People have. And they are working on a project to kind of drive this conversation forward. And that project is a project called Standard Lib, which is a standard library for JavaScript and Node.js with an emphasis on numeric computing. And it consists of over 1,000 packages right now and is growing, still very much in active development. And it has things like robust implementations for statistical functions or special functions. It also does things for like floating point manipulation. It has plotting utilities. It has generic utilities that you might find in Lodash and async. It's a standard library. Other thing it has is it has a growing and extensive list of random number generators that you can seed, unlike in the standard math library. Another thing that comes with an integrated REPL. So what I'm going to show here is that the help documentation for a BLAST implementation, because the project also provides wrappers around C, C++, and Fortran code to allow you to run BLAST or LobPack through Node or using WebAssembly in the browser. Very cool, right? So it's a help implementation just like you might find in Python with NumPy. Similarly, if you've used R and you're familiar with like their nice thing with the REPL where the REPL help, you can run the example. So here you can take a function, pass it to help, and then all that stuff gets evaluated in the Node REPL, and you can go back and interact with it to learn more about the implementation. So it's a standard library. I mean, the project I like to think about it in terms of it is a core foundation that you can use to build robust statistical libraries, machine learning libraries, artificial intelligence, anything you need to do with numeric computing. And in case you're worried that I'm one of those like false prophets I talked about earlier, the project also comes with an integrated bibliographic database with all the primary resources we use for all the implementations. So you can check this stuff out on your own. The other thing that it comes with extensive testing against reference implementations like Julia, R, and Python, including benchmarking. So you might be going, OK, that's awesome, right? You solved all my problems. We're going to the top. We're almost done. But alas, it's still very much in development. I mean, me personally, I've been working on this full time, living off of savings for the past year to kind of like drive this forward because I believe in it. But the reality is it's still very much an alpha. You could use it, but things could change. And if it's like mission critical code, you probably don't want to do that. But what is needed in order to drive this conversation forward is your help. Your help is needed to write robust implementations, to do testing and documentation, to really make JavaScript a first-class computing language. So hopefully, I've shown you that there is a light at the end of the tunnel, and hopefully, you'll help us get there. So with that, thank you very much. And if you're interested in the project, there's a link. And if you want to help crowdfund the project, there's also a Patreon link. Thank you very much. And does anyone have any questions? I can take a few questions, I guess. Yes.
I guess just like personally, what's your vision for how you keep sustaining working on this yourself?
Real hard question.
Right. It's a good question. I mean,
Patreon's part of it, I guess.
Yeah, I mean, but one that's kind of I'm exploring. I haven't like officially even launched that. So I mean, there's a few ideas. Like one is that you can do grant funding, but that typically is like a bit more limited, and it also requires sometimes legal status. So it just depends, and a lot of times grants are very much focused. Other way is, well, personally me, I could contract. Ideally, what would happen would be like corporate sponsorship, similar to how Node worked. Hopefully, people will buy into this and think that it's actually a good thing to bring to the Node ecosystem. For now, like my runway is probably to the end of the year, and during that time, I'll probably evaluate what the best way is to try to make this sustainable. Cool. Did you have a question?
Given that NumPy is a wrap of G-Fortran for numerics, how do you anticipate the handling of large significant digits in this compared to that? What advantage is there going here compared to just figuring a way to build Fortran?
Well, okay, so right. So so just to be clear, like Python, when it calls down to Fortran, it calls down to these other libraries, right, that have existed for 20, 30 years. Okay, we call into those same libraries. So the advantage here for people would be that, and this is true of my own experience. Like I was working for a small startup, and we didn't have like the DevOps bandwidth to have a polyglot architecture. We wanted to be able to do everything in Node. So for us, there was an inherent advantage or a business case for why we wanted to be able to do numeric computing in JavaScript. That's what we pursued. I did things where doing in-browser computing as well as on the server for analyzing server data. So there's a clear business case just in terms of like bandwidth for small companies. For larger companies, what's interesting is you can think about, like with Node.js native add-ons, you can have asynchronous workers. So you can do computational, like let's say large-scale data sets. You can farm those out to async workers through native add-ons and still receive requests. If you were to try to do this in R, you'd block the entire server the entire time, right, until that computation finished. So you can take advantage of the asynchronous nature of Node and also JavaScript to do efficient computation. So there's some structural reasons, and there's also just reasons like you don't want to have, if your developers are already used to writing JavaScript and already used to writing Node, they don't need to learn some other language in order to be able to take advantage of numeric computing capacity.
So you're basically writing a replacement to NumPy to use it?
Yes. You can think of it like that, yes. Yeah.
If you aren't in the client, and I recognize that is a big superpower,
Right.
Is there something that you can say, Node and standard lib right now is going to be like, we're not better at everything, but there's something right here that's actually better than NumPy in particular?
Performance. I mean, performance, right? So the thing is like with JavaScript, it's a very good scripting language. And as a scripting language, it is more performant. It could be like 2x to 2.5x more performant than in Python, right? Python is a little bit slow when it calls it into its C interfaces, right? The one advantage that Python has is like Cython, so where you compile into C code, but you can easily imagine doing a similar thing with Node and with JavaScript, right? So I'd say performance. Another thing is to be able to tap into a very large developer community. Another thing is this package management, et cetera. I mean, I think the Node.js ecosystem is the powerful sell here, and what you can do, the potential applications that are just not as easily accessible in these other languages and other environments. Yeah?
Thanks. So how many other contributors have you racked up over the last year working on this?
So there's a guy I work with at Carnegie Mellon who works on this basically part-time, who's building an online e-learning platform that this is being used in for data science and statistics. And then there's been 3 other contributors that have worked on various implementations within the library. Yeah.
So as they exist right now, in your opinion, which is faster, Python or Node? I asked this a while back on Reddit and I didn't get it.
I mean,
You asked that on Reddit?
yeah. I mean, look, what I can.
In your opinion.
Like, as I said, as a scripting language, JavaScript is faster, right? There are some issues with using typed arrays in Node when you interface with Node.js native add-ons, right? There is some computational costs there that could be improved. But hopefully with the Node stable ABI coming around, like we'll see some performance improvements with that. So there can be some issues there, but the nice thing about that is you're just using the same binary buffer underneath, and so you're just passing a pointer. So there is some advantage there, but a lot of times you end up having to copy that into a new C array or C vector, and that can be a little bit costly. So there are some things we can improve to make it even faster. But my personal opinion is that JavaScript and Node.js has a lot more runway than these other platforms, and is quite performant for what it does.
Maybe one more?
One more. Yeah.
Is plotting or graphing part of this, or would you recommend pairing it with something else?
Yeah, so this the library also includes plotting and graphing. And in particular, it does server-side rendering using virtual DOM, if you're interested in this. That way you can do different outputs. So you can save HTML, or you can go to SVG, or you can put this into the browser and you can render as WebGL or whatever. You can pretty much tie this into anything. And it also includes, if you're doing like headless stuff, it also includes an ASCII plotting thing. But anyway. So yeah, there it is. Thanks.